Module 1, Footwear Performance and Comfort. Unit 2, Mechanical Comfort and Footwear Performance.
Lesson 2.5. Bending and Torsional Characteristics of the Sole. This lesson is structured as following.
Definitions. Concepts and theory. The influence of footwear bending and torsional characteristics. Analyzing bending and torsional characteristics. Innovative solutions to support bending and torsional characteristics.
Definitions, concepts and theory.
Bending and torsional characteristics of the sole structure take place during walking, running and other movements. During walking, the human foot has to bend from the mid-stance to the push-off phase of the gait, walking, cycle, and it twists at heel strike, and then the twist is reversed at push-off. Torsional shoe stiffness is the resistance of a shoe to twisting about its long axis between the heel and toe box, and is linked to changes in foot and ankle kinetics and kinematics during running and cutting motions.
Bending occurs at the push-off phase, Figure 3, and takes place with the part of the sole between the metatarsals and toes foot area, and the ground fixed, about at 26% of the full length of the foot, Xiong et al., 2013b. Therefore, the sole structure is bent upwards and the angle between metatarsals and toes is about 55 degrees, which is also the angle of deformation of the sole plate in relation to the floor level. Natural twisting of the foot occurs at heel strike and the push-off phases of walking, Kirtley, 2006. It also takes place due to pronation or supination of the human foot, which happens to most humans and it is not considered abnormal. Changes on the floor contours may also induce torsion on the sole structure. It is also known that the lower the resistance to twisting, the more comfortable the footwear is. Twisting occurs at 4 different cases, at the front and rear part of the structure, as well as on positive and negative sign, left and right rotation. Typical angles of twisting are of the order of 15 omicron. In any case, one end of the sole structure is fixed while the other under torsional deformation. As it is the case with bending, it is the area to the front of the metatarsal joints that is fixed during push-off and equivalent area at the rear part of the structure on heel strike. In any case, there is stored strain energy in the structure under torsion as in bending.
The influence of footwear bending and torsional characteristics.
In normal walking, if the shoes are quite stiff, but still bendable and twistable, they may cause tiredness and sore muscles when moving over longer distances. On the other hand, certain environments, for example rough ground, may dictate the use of rigid and even fully rigid boots, for ankle protection purposes or other special tasks. However, in these cases, the users are aware of the limitations of the product and adjust their walking style. For example, industrial workers wearing fully rigid protective boots tend to lift their feet rather than bending them.
Walking in flexible shoes is, generally, easier than in more rigid ones. In addition, there is a relationship between longitudinal torsion and comfort, as well as lateral torsion characteristics at the toe break line of the shoe, along the metatarsals, and comfort. Bending elasticity of the footwear in the forefoot region reduces the activation of the calf muscles but also enhanced both maximal anterior-posterior and vertical propulsive forces in the push-off phase to reduce push-off time.
Torsional characteristics are also important to comfort. There is limited research concerning longitudinal torsion of footwear structures and the effects of resistance to twisting on the comfort perception. The overall opinion is that for increased resistance to twisting, pronation around the heel area appears to be increased, thus causing discomfort and even pain.
Analyzing bending and torsional characteristics.
Studying bending, and to a certain extent, torsional characteristics makes sense only in fully fastened footwear that can follow the movement of the foot and reasonably bend or twist. Engineering theory as well as simulations with finite elements, Papagiannis et al., 2017, have shown that there is high positive correlation between bending and torsion strain energy characteristics. Therefore, if a shoe is very bendable, it is also very twistable. Overall, the less rigid is a shoe, the better. The best approach to studying bending and torsional aspects of mechanical comfort is through energy or work metrics. In flexible shoes, the most comfortable ones, work requirements for bending or twisting of the sole structure are less. Bending and torsional characteristics of the sole structure depend on sole geometry and materials only and do not require the use of biomodels for simulations. For soles with identical geometry, it could be argued that relevant studies could be restricted to measuring forces or moments. In fact, several proprietary testing arrangements for bending and torsion of footwear specimens, CTC flexometer, DNO, INDMPO torsion tester, depicted in Figure 1.4, calculate such measures. However, this is not the most practical approach when fundamentally different designs have to be tested, which is often the case.
Innovative solutions to support bending and torsional characteristics.
In 2019, BASF announced its innovative polyurethane systems for the footwear sector and Ultrasim, a computer simulation software developed to produce torsion-resistant footwear inserts. The torsion-resistant insert is positioned inside the footwear, between the inner sole and the heel, to maintain its shape and to increase comfort. Rigidity is the main property of the materials used for these inserts, which is why they are often made of polyamide, reinforced with glass fibers. BASF has developed a new solution involving the use of thermoplastic polyurethane, TPU, also reinforced with glass fiber. BASF's new Elastilin series has the stiffness of other materials, almost without absorbing moisture. The application of BASF's Ultrasim simulation technology allows the production of lighter TPU torsion-resistant inserts, as it is efficiently designed, using less material and with consequent cost savings.